Hi guys, welcome to the last lecture of the hands-on LLM course. Today we're going to deploy the LLM that we created into a RESTful API. How? We're going to build a LangChain agent that is going to load the LLM that we fine-tuned and saved in the model registry. Then it's going to build the entire chain, which is going to have two components: the content extractor that is going to be responsible for fetching the relevant piece of news from the vector DB, and the LLM component that is going to use this information plus the user query to generate the response. So when the RESTful API is up and running, it's going to listen to incoming requests, it's going to fetch the relevant piece of news from the vector DB using k-meter search, it's going to pass that enriched prompt, the fine-tuned LLM that we created in the previous lesson, and then it's going to output a response to the user, which is going to contain sound financial advice. Finally, we're also going to log all the prompts, outputs, and metadata to the prompt management tool that Comet provides. This is a great way to track performance over time and to optimize your applications. And the best part, you won't need to manage any infrastructure. Why? Because we're going to use serverless ML tools. We're going to use Quadrant as our vector DB. We're going to use Beam to deploy our RESTful API. And we're going to use Comet as our model registry and prompt experiment tracking tool. Let's get our hands dirty. So I open the code, go to modules, financial bot, and here we can open the README. Here you usually have all the instructions you need to run this thing locally. But before running, I'm going to walk you through the implementation of this LangChain bot. So you go to financial bot, LangChain bot. Then here you have the class financial bot. This is a convenient wrapper around the model, the fine-tuned model, and a bunch of parameters we need to decide how we fetch data from the vector DB. If you scroll down in the init method, there's the build chain function. This is the function that builds our LangChain, which is made of two subchains. The first one is called context extractor. This one is responsible to connect with the vector DB and fetch the relevant documents from the vector DB given the user query. And then the second subchain is the LLM part, where the model is given the input prompt, which contains the user query and the context we extracted from the vector DB, and then it's passed to the LLM, which generates a response. This is the final response that we send back to the user. So here in this method, you can see the creation of this first subchain, context extractor, the second one, and then in between, there's this callback. So LangChain allows you the definition, the creation of callbacks. And in this case, we implemented a monitoring handler. So what we do is every time there is a request entering into our LangChain bot, we want to log that to Comet LLM. So Comet provides an open source tool that allows you to track prompts, metadata, and also outputs. And this is very useful if you want to optimize your LLM app. This is an open source project, so you can go and check it yourself. You go to GitHub. So here's the repo. It's open source, so give it a start to support it. Going back to the code, we have defined the handler, the second subchain with the LLM, and then we put that together into what is called a sequential chain, which makes a lot of sense, doesn't it? We return it, and that's it. So this is a step where we create the model. And now when we want to run inference, when we call this chain, we define this answer method, which takes as inputs the about me section and the question from the user, and then it passes through the chain, which enrich it with the data from the vector DB, passes to the LLM, and then generates the response. You can run this bot locally, and for that you can check the README file. So if you go down in the README file, first you need to run make install to install dependencies locally. This is what I'm going to do now. Make install. Then before running it, you need to set up some credentials, which are in this .m.example. I created mine already, so I'm going to show it to you. Here we define Comet ML specific secrets, so an API key, a workspace, and a project name. So to create this project name, you need to go to Comet. And then you check on the upper right corner, new project, you create one, you define the name that you want. And then very important, when you select project type, you need to check large language models. So this is a new tool which connects basically with the SDK that I showed you before, which is open source, that lets you log LLM chains. And that, as I said, is really important to debug and to optimize your application. So do that, create your project, give it the name that you want, and then in this .m file, set the name right here. So this way you have defined all the credentials you need to connect with Comet LLM. And then the second is Quadrant. So as we talked in the previous lecture, Quadrant is our vector DB. We use it as a serverless service, which means we don't need to handle infrastructure. So the only two things you need are the Quadrant URL. So that's the URL of your cluster, which is right here. And then the API key. So if you don't know how to get them, I recommend you go back to the previous video where I show step by step how to get these two values. So you save this file, then you go back to the README. So you set up Quadrant and Comet. So now it's time to run it. So I'm going to head down to the terminal and run our bot. Oops, I get an error. It says Torch not compiled with CUDA enabled. Yes. The problem is that right now the code as it is based on Hugging Face and a bunch of libraries which are only working if you have CUDA devices. So for example, if you don't have CUDA because you have an old computer or you have a MacBook M1 or M2 which have GPUs but do not have CUDA but Metal backends, this code still doesn't work there. So this is actually a great opportunity to show you how to use serverless. So we're going to deploy that to Beam, where we can choose a runtime which has a CUDA and GPUs enabled. So let me show you how to do that. First, to use Beam, you need to have the Beam SDK. So if you haven't done that before, go to beam.cloud, and then under Docs, Installation, you need to install the SDK. So you copy this curl command. I'm going to go to the terminal and run it just to make sure that I have the latest version of the SDK. Super, so I have it. But before running the Beam SDK, you need to configure. And to do that, you run beam configure, and then you need to pass the API key. To get your API key, you need to go to your Beam dashboard and then generate a key and copy it. So once you do that, you're able to connect with Beam. Now, let's go back to the deployment. To deploy it, we create one command, which is deploy Beam. Let's check what does this thing do. So when you do deploy Beam, we're basically calling the Beam SDK with the beam deploy command, and then we're passing a path to a Python file where we have defined our Beam application. So let's go there under tools bot.py. That's it. Here, first of all, we define what is called an app on Beam. And we define basically the hardware that we want to use to run it. So number of CPUs, memory, GPUs, also the Python environment, so Python version, and also packages. These are in the requirements file that we generate from our pyproject.tom. And then we define a volume. This is important because this is a place where we store the model, the LLM that we download from the model registry. We store it and we cache it. So this way we don't need to download it every time. So this is how we attach a volume. Super. And now, how do we run this app? To do that, we're going to run it as a REST API. So if you scroll down in this file, you're going to see we define a run function that has this Python decorator. It's decorated using the name of the app that we define and then .REST API. So this way, we tell Beam that we want to deploy this app as a RESTful API. Now, we pass a couple of parameters, keep warm seconds, and loader bot. What are these parameters, Paul?
When using Beam RESTful API features, there are two key components that you have to take into consideration. The first one is the keep warm seconds parameter, which tells you for how many seconds you want to keep the container alive. This is extremely useful because when you don't have activity on your deployment, the container will be turned off automatically, which will save you a lot of money. The second one is the loader parameter, which points to a function that loads all the resources that you need across your RESTful API. This is extremely useful because when the container is turned on, the resources are loaded only once and shared across all the API requests until the container is turned off. Hence, you need to load the resources, which are very time-consuming, only once.
Super, so let's run it. Let me go back to the README to check the exact command, make deploy Beam. So I go down to the terminal and I run it. Super. This is going to take a while the first time you run it because it needs to set up a bunch of stuff. But as you will see, it will redirect you immediately to a browser tab where you can check the logs. So as soon as this thing is up and running, you will see the logs. This is going to take a while, so I'm going to stop this video and come back to you in a second. Super, so you see the logs, the REST API is up and running. Let's test it. I'm going to go back to the README. And then to call it, we also define a command, which we call it call RESTful API. And for that, we need to pass two parameters, which are the deployment ID and the token. Where do you get this from? You need to go back to the Beam dashboard and then click on Call API. Here, this prefix before .apps.beam.cloud is your deployment ID. So I'm going to copy it, and then I'm going to set it, export Beam deployment ID to this value. And then the second one is this token, which is here. I'm copying it and then export Beam auth token. Super, so let's run the command. We call the RESTful API, and super, we get a response. You can go to the Beam dashboard and see the request, read to the server, and return a 200 OK status. Super. So that's it for today. I hope you learned something new. And don't forget to give us a star on GitHub. You will find the link down below in the comments. See you soon.